So today we'll be looking at multi-step inequalities, and we're also going to be talking about what inequalities are, what they mean, what their solutions mean, and just doing several examples of multi-step inequalities. So we're going to go through this first one and spend a little time dissecting it, then we're going to go through some more at a fairly quicker pace. So let's go ahead and talk about this first inequality. So we have negative 4 times 3x minus 1 plus 6x is greater than or equal to 16. So again, the big difference between inequalities and equations is inequalities use what we call sign of inequalities or signs of inequalities. We have greater than or equal to, and less than or equal to. Whereas with an equation, we use the equal sign, meaning both sides are equal to each other. Okay. However, in an inequality, typically that's not the case. Okay. And so let's go ahead and work through this first one, and we'll talk about what the solution means when we get there. So the thing is, you solve inequalities similar in most ways to how you solve an equation. So if we were to start solving this as an equation, first we would distribute. All right, so negative 4 times 3x is going to be negative 12x. All right, then negative 4 times negative 1 is going to be positive 4. That's going to be plus 6x is greater than or equal to 16. All right, now, again, what I would do in my next step is I would go ahead and combine my like terms. So negative 12x plus 6x will be negative 6x. Then I'll bring down my plus 4. It's kind of an ugly 4. And that is greater than or equal to 16. All right, so again, now we're down to what we call a two-step inequality. And now we will get rid of our constant. Okay, we'll subtract our constant from both sides. Okay, like an equation, if you're going to subtract 4 from your left side, you're also going to do it to your right side, because in an equation, you're trying to keep both sides equal, and with an inequality, you're trying to keep the left side as greater than or equal to the right side. So if you're going to take 4 away from the left side, you're also going to do that to the right side. All right, and now, so I'm going to have negative 6x left on my left side. It's going to be greater than or equal to 12. Now, in this last step, in an equation, what you would do is you would divide by your coefficient, meaning you would divide by your number that is in front of your variable. Okay, and you will also do this with your inequality. We'll do this on both sides, but what's different now is when you divide your inequality, when you divide an inequality with a negative value, so we're dividing by our negative coefficient, that negative 6, you're going to flip your middle sign. Okay, and that is the primary difference when solving inequalities as opposed to equations. You're going to divide by a negative, you're going to flip your inequality, your sign of inequality. So we get x is now less than or equal to, well, 12 divided by negative 6 is going to be negative 2. So x is less than or equal to negative 2. And so that's great that we got that, but what's that mean? Well, what that means is, typically when you solve an equation and you come down to a specific answer, that means your equation has one solution. And when you plug that one solution into your equation, you're going to get both the left and right side equaling each other. But with an inequality, when you plug in any value that matches this right here, then you will make the sign of inequality in your inequality true. So if I were to plug in a value less than negative 2, it would make my left side greater than my right side. So this side right here would be greater than 16. Now, when you have less than or equal or greater than or equal to, if you use the specific value that it is greater than or equal to or less than or equal to, it will make both sides equal each other. So if I were to plug in negative 2 with my x's right here and right here, it'll make my left side equal to my right side. All right, but if I chose anything that was less than negative 2, so if I plugged in negative 3, if I plugged in negative 15, whatever I plug in for x that is less than negative 2, it'll make my left side be a greater value than 16. Okay, so let's continue on. And let's go ahead and look at this next one down here. And this one actually is a little bit less involved. We have negative 3 times 2x plus 2 is less than 10. All right, and so again, first thing we'll do is we'll distribute. So negative 3 times 2x is negative 6x. Negative 3 times 2 is going to be negative 6, so we put minus 6. That is less than 10. Okay, so negative 6x minus 6 is less than 10. So now we're down to a two-step inequality, and what we're going to do is we're going to add 6 to both sides. Get rid of our constant, and again, a constant is just this value, and this is also a constant. It's a value that essentially doesn't have a variable with it, and so we want to get rid of the constant on the same side as our variable. So we have negative 6x is less than 16. Now 16 is not divisible by -6 evenly, so we're going to end up with a fraction as our answer. So again, like an equation, we want to divide by our coefficient. And now what we'll notice is, again, we are dividing by a negative value. We're dividing both sides by -6, just like we did up here. So when we divide by a negative value, what again do we do to our sign in the middle? Well, we flip it. Okay, so since we're dividing by a negative, we get x is greater than, okay, well 16 over 6, or sorry, 16 over -6. Well, a couple things we can do to this. First of all, we're going to write it like this, 16, or x is greater than -16 over 6. We're going to write it like that, but also we're going to simplify this. Now, I would suggest just leaving this as a fraction, okay, but this fraction can still be simplified. So both 16 and 6 are divisible by 2, so when we simplify it, we get x is greater than -8/3, and that is our answer right there. And so again, what this means is if you were to plug in any number greater than -8/3 into where you see this x right here, it's going to make your left side smaller or less than 10. That's the whole purpose of finding the solution. Okay, the solution set that you have are any numbers that are greater than the value -8/3. So if you chose -1/2, if you chose +6, any of those getting plugged into this x right here will make your left side less than 10. All right, so let's do another one. And now what this is it's an inequality that has a variable on both sides. Excuse me. So just like an equation, if you have a variable on both sides, you have to pick, okay, I need to move my variable to one side of the equation. And what we're going to do is, typically I tell my students, is let's just get rid of the smaller variable, okay, or the variable with the smaller coefficient, rather. And so what I'm saying is I have a 3.5x on my left side and a 1.5x on my right side. So I'm going to subtract my 1.5x. Now you might be thinking, well, why can't I just combine these as like terms? Well, when they're on different sides of the inequality, or if it was an equation, if they're on different sides of the equation, you can't do that. You can only do that if they're on the same side. But since they're on different sides, we have to get rid of one of them to move the variable to one side. And so the reason I like to get rid of the variable with the smaller coefficient is it leaves the coefficient on this side positive. So 3.5x minus 1.5x is going to be 2x, so 2x plus 19 is greater than or equal to -7. All right, so again, now we're down to a two-step inequality. So what I'm going to do is I'm going to subtract 19 on both sides, and I get 2x is greater than or equal to -26. And now if you notice, our coefficient, this 2 right here, is positive. Okay, so now since it's positive, when we divide by a +2, our middle sign is not going to flip. Our sign of inequality is going to stay the same because, again, we only change it when we have a negative coefficient that we're dividing by. So we get x is greater than or equal to -13. And what this means is if I were to plug in the exact number -13 in both places that I see my variable x, okay, it's going to make both sides equal to each other. Now, if I chose a number greater than -13, if I chose -12, -6, pi, whatever I chose, it would make my left side greater than my right side. Okay, so we're going to do two more. And now this one, I want you to go ahead and pause the video if you have pencil and paper and go ahead and try this yourself. Okay, so now that you've given it a try, let's go ahead and work this together. And now what I'm seeing is on my left side, I have 7x minus 3, and that's all over -4. Okay, and that's less than 6. So my left side is going to be lesser than my right side. And what we need to do, since our variable and pretty much everything is enveloped in this fraction, let's get rid of our fraction. And so to get rid of a fraction, let's just multiply both sides by our denominator. So we're multiplying by -4. And now here's the thing. Just like when we divide over here, like when we divide by a negative coefficient, where was it at? It was right here. When you divide by a negative coefficient, you flip your sign. Okay, same deal happens when you multiply the whole fraction by a negative number. So I'm multiplying by -4 so that I can get rid of my fraction and just get 7x minus 3 on my left side. Okay, and that is not going to be less than anymore because, like I talked about, if you divide by a negative value, you're going to flip your sign. But if you also multiply by a negative value, you're going to flip your sign. So now this is greater than, and 6 times negative 4 is negative 24. So now we end up with this inequality, 7x minus 3 is greater than negative 24. All right, so now we're down to a two-step inequality again, which is nice. So we're going to get rid of our constant by adding 3. We're going to add 3 to both sides. Those 0 out, we get 7x is greater than negative 21. And the last step is to go ahead and divide by our coefficient, which is 7. And now since that coefficient's positive, we're not going to flip our sign. Okay, it's going to stay x is greater than negative 3. And so again, let's think about what our solution means. Okay, this time let me go ahead and clean up the equation a little bit if I can. Oh, apparently won't erase. Okay. Well, in our equation, if I were to plug in a negative 3 right here, that would not make the inequality true, right? Because the solution says x is greater than negative 3. So if I chose any value greater than negative 3, it will make my left side smaller than my right side. Okay, so if I chose 0 to go in for x, or if I chose 1, or if I chose 1,000, or if I chose negative 2.5, any of these values that are greater than negative 3 would make my sign of inequality true and make the left side of the equation lesser than my right side. Okay, so this video is getting kind of long, so let's do one more equation, and we're going to come down to this one right here. Okay, and so like the last one, go ahead and pause it and try it yourself if you have pencil and paper. Okay, and now we're going to go ahead and solve this together. So I see variables on both sides, so what I'm going to do is I'm going to distribute. So 3 times v is 3v. 3 times negative 4 is negative 12, so 3v minus 12 is greater than or equal to 5v minus 24. Okay, so two different routes you could take. When you have variables on both sides, I should have mentioned this earlier, but you can get rid of either one of the variables. You can get rid of the 3v or the 5v, and your answer is going to come out to be the same. What I'm going to do is I want to leave the variable on my left side, so I'm going to go ahead and get rid of my 5v. So I'm going to subtract 5v from both sides. Okay, when I do that, I'm going to be left with negative 2v minus 12 is greater than or equal to negative 24. All right, and so now, again, just down to a two-step inequality, so these are pretty easy to simplify down. So we're going to add 12 to both sides, so we're getting rid of our constant. We have negative 2v is greater than or equal to negative 12. Now, we're probably noticing that our coefficient is negative, and so we're going to divide by negative 2. And so the nice thing is on this side we'll get a positive value, but also when we divide by negative, remember, we're going to flip our middle sign. So we get v is less than or equal to positive 6. And now in this last one, again, this is the file I used to teach my students this. With v is less than or equal to 6, we can put that on a number line now. We can graph it, and what we're going to do is we're going to say, okay, well, v is less than or equal to 6, so we're going to fill in, it's kind of a big circle, but we're going to fill in, like shade in a circle, because we're saying 6 can be a solution to this inequality, okay? And then anything less than 6 can also be a value, because v, our variable, is less than or equal to 6.